material, if you could find a spoon strong enough to hold it, would weigh the same as Mount Everest, about 1 billion pounds. Think about that. On a neutron star, the crush of gravity is so strong, it would be like condensing the highest mountain on Earth down to a spoonful of sugar. Some neutron stars have magnetic and rotational axes that are misaligned, and they spin wildly in space with brilliant beams of light sweeping the skies around them. It wasn't until 1967 when scientists observed a flashing star in distant space. They were seeing the beams of a special kind of neutron star called a pulsar. The recently discovered Black Widow pulsar earned its nickname by sucking the life out of a companion star that orbits around it every 93 minutes. Mass from that companion star is being absorbed by the tremendous magnetic field of the pulsar. It spins at nearly 400 times per second, emitting a pulsing beam of light. Sadly for the companion star, this breathtaking dance will also be brief. In just 100 million years, the Black Widow will eventually devour its mate. There are so many forces in the universe, some beautiful and some unimaginably powerful and violent, as we'll see when we come back. A pebble with a nearly insignificant mass. But what if it struck with just enough force to knock an asteroid ever so slightly off its trajectory? These are the kind of random, unpredictable collisions, 1,000,000 to 1 odds, that happened millions of times billions of years ago when our solar system began to form. A chance collision, changing the path of an object so slightly that 1,000 years later, it finds itself heading straight for a random early planet. Collisions like these help shape how every solar system in every galaxy would eventually form. A new debris field is born, and a planet gets a new crater. Gravity will pull most of the debris back in, but some of it will escape and go on to become yet another clump of travelers looking for their next encounter. Four and a half billion years ago, one of those travelers brought us a collision for the ages. Scientists call it the Giant Impact. A protoplanet named Theia, the size of Mars, was on a terrifying collision course with early Earth. The impact was devastating. Theia sheared Earth to its core. Material from the Earth's mantle, as well as what remained of Theia, was ejected into orbit. The debris from that impact, the dust, the rocks, and the molten magma from the core of the Earth, went on to become the rocky satellite we call the Moon. As violent and terrifying as that collision was, It also controlled our destiny. For without it, there would be no moon, and life on Earth, evolution itself, would not have been possible. Elsewhere in space, there are meetings so huge they seem like science fiction. They are spectacular collisions within tightly packed star clusters. It is believed they happen when older, smaller stars are drawn together by gravity. They orbit closer and closer. Sometimes a smaller one will actually plow right through a larger one. In galaxies across the universe, this solar dance plays out on a scale that's unimaginable, with sun-like stars hurling toward one another at remarkable speeds. They meet in spectacular displays. A massive collision of light and gas and debris. The result? A star that's more blue than most stars in the cluster. They are called blue stragglers. But several stars coming together in space is not the largest collision the universe has to offer. The Hubble telescope has recently discovered two star clusters that are in the process of colliding in the massive star-forming region known as 30 Doradus, or the Tarantula Nebula, more than 170,000 light-years away. Gravitational forces are drawing these star clusters closer and closer to each other, into a dense, extraordinarily bright and gaseous region. Astronomers believe they are witnessing a strange and powerful force in the universe, and the creation of a luminous new neighborhood inside the tarantula. And when any new neighborhood is formed, not everyone sticks around. Scientists have discovered what they believe is a runaway star from that massive merging inside the Doradus Nebula. Most stars, like our Sun, move in proper motion, but not this one. Scientists believe at least one runaway star was ejected during an interstellar collision. The star they have their eye on is a gigantic body, 90 times heavier than our own Sun, and traveling at more than 250,000 miles an hour. It is believed that this homeless runaway star has already traveled 375 light-years from its stellar nursery home. A real shooting star, if ever there was one. Next, we'll see a collision that came dangerously close to Earth, relatively speaking, just 20 years ago. And cameras were there in space to capture every breathtaking moment. On March 24, 1993, astronomers Carolyn and Eugene Shoemaker, along with David Levy, were in a California observatory when they discovered a fragmented comet orbiting Jupiter. NASA trained the Hubble telescope on Jupiter, and the Galileo spacecraft was already on its way to observe this rare event. This would be the first time we would be able to watch an impact on a planet that was not our Earth. Further observations revealed that the comet, now named Shoemaker-Levy, was once a massive comet that had been trapped by the giant planet's gravity. It began to break up after a recent close pass. That 700,000-mile train of comet rubble was expected to return and collide with Jupiter in July the following year. In early July of 1994, a meteor shower began to rain down on Jupiter. One by one, the larger fragments of Shoemaker-Levy, mountainous boulders, blasted through Jupiter's atmosphere at 134,000 miles per hour. Some vaporized instantly, but the more massive comets drawn by Jupiter's powerful gravitational pull created giant fireballs and shock waves that rippled across the planet. They ripped a hole in the planet's atmosphere that was larger than Earth. Scars from the impacts were more visible than the Great Red Spot. They lasted for months. It was the first direct observation of an extraterrestrial collision in our solar system. And a violent demonstration of the force of Jupiter's gravity. The largest planet in our solar system, Jupiter has more than 60 moons circling around it. Its 4 largest were first observed by the astronomer Galileo more than 400 years ago. But the planet also has dozens of smaller, irregularly shaped moons. Asteroids or comets, really, that were caught by Jupiter's strong gravity and taken into orbit. The planet simply collects objects in space. The largest planets orbiting our sun can be found in the far reaches of our solar system. They are the gas giants, like Saturn, Uranus, and Neptune. Jupiter is one too, and it may look as solid as rock from space, but the planet is made mostly of hydrogen and helium, along with some ammonia and methane. It is a massive planet, but made almost entirely of gas. Standing on the surface would